etc. And the last one on this table is the 7926G, which includes a barcode scanner for tracking inventory. Now, it's interesting to note that these phones are ABG. They are not N enabled, but they do allow you to roam between the 2.4 and the 5 gigahertz band, so they will work on both frequencies. So when you think about the type of problems that you could get on a voice network, they could be the fact you're getting an echo, you could have gaps in the speech, you could lose connections while you're roaming, or you could even be able to hear, but the other person not be able to hear you. When you have those type of problems, a lot of the times they're actually caused by the RF environment itself. It could be a weak signal or no signal at all. It could be when the device can hear the access point, but the access point can't hear the device. It could even be a problem with the way that the network has been configured to support quality of service. Maybe some of the mapping between the class of service on the wired network and the class of service on the wireless network have not been done correctly. So there's a range of different problems that could occur. When we look, therefore, at saying, is your wireless LAN ready to support voice, there are a number of things that we look at. The first one for optimum performance is we want to make sure that when the handset reaches the edge of the cell, where the edge of the cell is defined at minus 67 dBm, that at that point is transitioning and handing over to another access point. And in order to ensure that you've got high availability and the ability to hand over to another access point, we want to have the access point coverage actually overlapping. And because of the interference in the 2.4 gigahertz band being higher than what is normal in the 5 gigahertz band, we normally look for 20% cell overlap in the 2.4 gigahertz band and 15 to 20% cell overlap in the 5 gigahertz band. You also want to limit the number of simultaneous calls, and overall channel utilization when you're supporting a voice network should be less than 50%. We talk about 14 voice calls in the 2.4 and 20 up in the 5 gigahertz band, but it really does depend on the RF environment. How much interference is there? Are there other devices operating in 2.4? If there's none, then you're going to find you're able to get more than 14. If there's a lot of interference, then you're going to find it's going to be less than 14 calls. When you do a measurement assessment of how good is the quality of the voice call, then typically what Cisco's looking for is a retransmission rate of less than 20%, the packet loss being less than 1%, and the jitter should be less than 100 milliseconds. Now, because the RF environment is constantly changing, when you're surveying for a system for voice calls, the signal strength and the signal-to-noise ratio, you actually want higher than what you actually need for a voice call. So if you have that fluctuations during the day, your voice call quality will not be affected. Now remember, these measurements are for planning purposes, and as we talked about in the previous section, walking the floor with the user's device, making sure that they can effectively roam, looking at the roaming statistics when they transition between access points, you really need to do that. So this is a great tool for planning, but you still need to get out into the field and actually walk the path of a user and check that this is conforming to what our planning tool is telling us. So in your Cisco wireless control system, from the same drop-down menu that we selected planning mode, there is also an option to inspect the voice wireless LAN readiness. And when you select that, it'll bring up this screen. Now by default, the tool will show the areas that meet the minus 67 dBm threshold value required for the Cisco IP phones. If you were deploying a Vocera badge, for instance, which has a requirement of -65 dBm, you can select Custom, as shown here, and enter the desired received signal strength for your specific devices. And then the color scheme indicates whether or not the area is ready for voice. So this green area is voice ready, the yellow area is referred to as marginal, and the red area is indicating where the signals are so weak that you're not going to be able to make a quality voice call. Now remember, this is a planning tool, and so it's very important that you take some measurements out on the floor in order to verify this before you make the assumption that you need to start adding access points. It is also a good idea that you recheck the power levels have been set correctly on these access points and see whether you can actually increase the power to get better coverage where the yellow and the red areas are, while still maintaining a balance, because again, you don't want the voice device to be able to receive the access point signal, but the voice device not be able to communicate back to the access point. So just blasting up the power of the access point is not going to give you a solution, but you should certainly make sure that it's at the maximum that it should be in order to maximize the areas where it's green and minimize the area where it's red. So one of the tools preferred by Cisco for going out into the RF environment and taking measurements on voice performance is the tool that we were talking about earlier, the ear magnet analyzer. And if you remember, I told you that the Pro version included a voice over Wi-Fi tool. And that's what you're looking at on this slide here. And this tool is actually the primary solution that's used by the Cisco escalation and advanced service teams that go out and manage and fix problems and optimize deployments of Cisco's unified voice wireless LAN. One of the nice things about this tool is that it already has the profiles for the Cisco 7920X series IP phones already pre-configured. And in this picture, you can see it's analyzing the different calls, and down here, it is providing the roaming analysis. And it's looking at the received signal strength, the packet transmission rates, and other things that can help identify problems if the client is handing over too often between access points. Now, the location readiness tool is similar to the voice wireless LAN readiness tool, and is going to verify that the received signal strength levels are sufficient to allow the location to be accurately predicted. So if you think of the site plan as being a series of points, each point on that plan is considered to be location ready, i.e. you can locate a device at that point if it can be heard by at least 4 access points, where there's 1 access point in each quadrant. And you can see that in the diagram over here on the right, where you see I have 1 access point in the 4 quadrants surrounding the specific point that's to be location ready. In addition to that, I need at least 3 access points to be within 70 feet. So the picture here shows the Inspect Location Readiness feature, and this is a distance-based predictive tool that's identifying areas that are not ready for location services. And here you can see, much simpler than what you saw with the voice, which used 3 colors, here is either ready or is not ready. And so the green areas are ready for location services and the red areas are not. So I've talked a few times in this lesson about the need to align the predictive model with the measurements you're actually getting when you go out onto the floor. And the way we do that is through calibration. So the last thing I wanted to talk to you about was how to use calibration with the Cisco wireless control system. So what's actually happening here is that you go out and you do some measurements, and then the tool uses those measurements to say, let me tweak the parameters in the tool such that I can then predict results which are closer to what's actually being measured. Now, the nice thing of this approach is that if you have several floors which are laid out the same, then once you've calibrated one floor, you can actually apply that calibration model to different floors. But of course, if your floors are very different, then you'll need to calibrate each floor and each work area. Now, there are two types of calibrations. One's called the data point collection, and the other is called the linear point collection. And the latter one is actually shown in this diagram. Now, the data point collection, as the name might suggest, is where you go to a specific point, a specific location, and you take a measurement there. And then you go to another location and take a measurement, and another location, take a measurement, etc. The linear point collection is when you start at one point and then you walk. And so you follow a path to another location, and it collects data points as you're walking that path. Now, the linear point collection is faster because you literally go to the point the tool's telling you to and walk to the end point and you're done. The data point collection is go to each of these locations and take a measurement, so it takes longer. However, you shouldn't think of this as one approach or the other. It's quite common that you use the linear point collection first, and then for areas that perhaps have been missed or are still causing problems, then you would go in and do the data point collection. Now, to get to this tool, you follow the same things as before. You go into maps like we did for our planning and location and voice readiness, but this time from the command drop-down menu, you select the RF calibration model. You can then select the add data points or do a linear point collection. You then simply enter the MAC address of the device that's going to do the calibration, and then off you go and perform the calibration. So in the case of the data point collection, that's normally finished when you've got about 50 distinct locations and about 150 measurements. And if you're using the linear point collection, then obviously it's finished by the time you've walked from the start to the finish and you select the Done button. A word of warning: if you're using this tool, if it comes up and says that the data collection bar is completed, keep going until you actually reach the end point. Do not stop data collection until you've actually got to the end and press that Done button. Once you're done with the data collection, the Cisco wireless location appliance will then analyze all of that data to understand the RF propagation characteristics. Once this is done, it'll display a map showing all the RSSI readings, and you'll get a measure of the location quality. That is the ability for the location appliance to find the device within 10 meters 90% of the time. Wow, we've come such a long way. We have now checked our wireless LAN has the required coverage, that roaming between the access points is working. We've checked its readiness for voice and its readiness for location services. So now what we want to do is create our